Hi everyone, welcome to the next lecture on ordinary differential equation. In this video, we are going to discuss the reduce the differential equation in the form of variable separation. Yes, there is a specific case. So how to identify that? See, these are the two examples. Here, the whole function raised to the power 2, and if you observe this second question, so there is an angle of sine is in the form of addition of x and y, and here also it is an addition of xy. So in any question, if you find the similar type of bracket, then that bracket we have to put as a new variable. So ultimately that is nothing but the equation converted into the variable separation form. So see how to solve this question. Here this bracket I have to consider that by new variable. So let's suppose that 4x plus y plus 1 I will consider as a new variable t. Here y is our dependent variable and it is depend on x. So x is an independent variable. So differentiate this term with respect to x. So when we differentiate by x, so first term derivative is 4, second term is dy by dx plus derivative of constant term is 0 and derivative of t is dt by dx. Now we are converting in the variable t. So obviously we have to put this dy by dx in the form of dt. So therefore this dy by dx is nothing but dt by dx minus of this 4 plus 4 shifting will be minus. So derivative answer we know, and similarly this bracket term we are considering as a t. To put this value in this equation, so you will get left side is dt by dx minus 4, right side is t square. Now in the next step, this minus 4 you have to shift in the right side. So you will get dt by dx equal to t square plus 4. Now this is a function of t. So shift this t term left side so that we can separate the variable to t square 4 dt equal to this dx shifting will be multiply. So it is a dx. Now the c variable are separated. So next step is just integrate both the side. So once the variable are separated, so you just have to integrate both the side. So you will get integration of dt divided by t square plus 4 we can write 2 square equal to integration of dx plus integrating constant c. Now integration of left side is a standard formula 1 upon 2 tan inverse of t by 2 equal to integration of dx is x plus integrating constant c. But here t is nothing but our 4x plus y plus 1. So put the value of t here. So we will get 1 by 2 tan inverse of, here it is a 4x plus y plus 1 divided by 2 equal to x plus c. So hence we get the solution of our differential equation. So simply bracket term you have to consider as a new variable t. Now see the solution of next question. Here the same bracket is x plus y. That means you have to put x plus y as a new variable. So consider any variable, it's just a notation. So I will consider x plus y as a new variable. Consider t for understanding. Now differentiate throughout with respect to x. So derivative of x differentiate with respect to x. So derivative of x is 1, derivative of y is dy by dx, and right side is dt by dx. So from this term we can say dy by dx is our dt by dx minus 1. This plus 1, right side shifting will be minus. Now put this value in this equation. So left side is dt by dx minus 1, right side is sine, here a bracket term is nothing but t plus cos t. This is a function of t and we have to separate the variable. So firstly this 1 I will shift in the right hand side, then it become a dt by dx equal to sine t plus cos t plus 1. Now whole term is contain t, so this bracket term if we shift in left side, so then we will get 1 upon sine t plus cos t plus 1 dt and here equal to dx. Now in the next step, we just have to integrate this term. So we will get integration of 1 upon sin t plus cos t plus 1 dt equal to integration of dx plus integrating constant c. Now here is a challenge. Separation of variable, putting this bracket as a t by identifying this question. It is simple, but the challenge is how to solve this integration. So for a moment, pause this video, try this integration, because in this question it is very simple to identify its type and put that x plus y equal to t. But the challenge is how to solve this integration. Here direct formula of integration is not available. You have to convert this sine and cos in the form of tan half angle formula. Here sine we can write sin t, we can write as a 2 times tan t by 2 divided by 1 plus tan square t by 2, and cos, here cos also you have to convert in the form of tan. So here 1 minus tan square t by 2 divided by 1 plus tan square t by 2. So in the denominator it is a sin t plus cos t plus 1. So sin is our 2, tan t by 2 divided by 1 plus tan square t by 2 plus here 1 minus tan square t by 2 divided by 1 plus tan square t by 2 plus 1. Now the first term denominator is same, so numerator we directly add. So we will get 2 tan t by 2 1 minus tan square t by 2 divided by 1 plus tan square t by 2 plus 1. Now here cross multiply this term. So this term multiplied by 1. So we will get here 2 tan t by 2 plus 1 minus tan square t by 2. This term I am writing as it is. Now this term you have to multiply with 1. So here we will get 1 plus tan square t by 2 and whole divided by 1 plus tan square t by 2. Now similar term you can subtract. Here t square and tan square plus term, tan square minus term is 0, plus 1 plus 1. So it is a 2. So therefore the remaining term is here 2 tan t by 2 plus 2 divided by 1 plus tan square t by 2. So from this numerator term we can take 2 common. So 2 is common. So remaining is tan t by 2 plus 1 divided by 1 plus tan square. 1 plus tan square we can write as a secant square t by 2. Now this term if we put in this integration, so our integral become here 1 upon. So 1 upon means here it is a sine plus cos plus 1. Here sine plus cos plus of 1 equal to this one. So reciprocal of this term sine plus cos plus 1, if we take the reciprocal both the side, so it become a secant square t by 2 divided by 2 tan t by 2 plus 1. Here 2 is a throughout common term, so I will write here bracket. Now put this value in this integral. So we will get secant square t by 2 and 2 constant throughout is there. So 1 upon 2 I will write as outside of integral because it is a constant, divided by tan t by 2 plus 1 dt, and right side integration of dx is x plus integrating constant c. Now here this is a very simple to solve because derivative of this term is contained in the numerator. Derivative of tan is secant square t by 2. So if the derivative of denominator function is contained in the numerator, then that integral become log of f of x, means log of this denominator term. So tan derivative is present in the numerator, tan t by 2 plus 1 is present here, but it is a 1 by 2 with 1 by 2. So otherwise you can put as a t. So here if we take tan t by 2 plus 1 as a new variable, suppose p. So derivative of this term is, derivative of tan is secant square t by 2, again derivative of angle term, so it is a 1 by 2 dt equal to dp. So put this term here, so that's why we will get here 1 by 2 and this term is nothing but our dp and denominator term is our p equal to x plus c. I again repeat this term, this bracket we are considering the p, so bracket term we are replaced by p, and this sec and 2 dt, this 1 by 2 sec dt is nothing but our dp, that's why here it is a dp. Now this integration is log p, here x plus c. Put the value of p, it is the p is our tan t by 2 plus 1 equal to x plus c. Now put the value of t here, t actually it is at x plus y. So here log of tan x plus y by 2 plus 1 equal to x plus c. So in this way you have to solve this question. So we have started with putting x plus y equal to t, but this integral is not possible, that's why sine and cos we have put as in the form of half angle tan formula. So we will get the simplification, that simplified answer I have put it here. So we will get the integration of that function, and after integrating put the value of p in the form of that t, and again t we have to put in the form of x and y because our original question is in the form of x and y. So I hope it is clear to you. Thank you for watching. Share this video with your friend, and if you are the new on my channel then must subscribe the channel. Thank you for watching.